Hi everyone. So welcome back to yet another video on this segment tree series. So today in this video we will be discussing about this interesting problem on Codeforces that goes by the name Sereja and brackets, and this has been asked in Div 1 round 223 and this problem is rated 2000, right? So let us start now with the problem. So the problem reads like this, that Sarija is the name of some girl and she has a bracket sequence from S1 to Sn. So she has a string of size n, right? And this string only consists of two type of characters, that is either the opening bracket or the closing bracket, like this as given in the example. So Sarija needs to answer some m queries and each of them is described by two integers, that is Li and Ri. To answer the ith query, she needs the length of the maximum correct bracket subsequence of the given sequence, that is the given string. Help Sarija to answer all the queries. You can find the definition for a subsequence and a correct bracket sequence in the notes. The first line contains a sequence of characters, that is the given string, and the length of the string can go up till 1 is 6 without any, and each character is either a opening bracket or a closing bracket as I told you before. And the second line contains an integer m, that is the number of queries, which can go till 1e5, and each of the next m lines contains a pair of integers, which would be our Li and Ri for each query. So we have to answer the given requirement in this range, that is the description of the ith query. And in the output we have to print the answer to each question on a single line, that is on a new line. So print the answers in the order they go in the end. So this is our question and this is the given example. So we will discuss this example in the blackboard soon. So let me zoom this a bit so you can see better. So as you can see that this is our given string that consists only of either the opening and the closing brackets, and there are 7 queries given in this order, and for these 7 queries there are 7 outputs like this. So this is our question, and we will first see how we can solve this problem, and we'll also try to code the brute force approach if possible. And after doing that we will come to the optimal approach that uses a segment tree. So initially after reading the problem it is quite hard to determine how this problem will be solved using a segment tree, because till now most of the problems that uses segment tree are performed in an array, that is array of integer. But in this problem we are given just a string consisting of the alphabetic characters, right? So you don't have to worry about anything. I will tell you in very detail how this problem will be solved using the segment tree. So let us now come to the blackboard and understand each and everything in very detail. So this is the given example in the question, but before moving ahead, let us first understand the meaning of a subsequence and the meaning of a correct bracket sequence. So how do we define a subsequence? So most of you must be knowing this by now, that a subsequence is a part of an array or a string such that we move in one direction from the starting index to the ending index. It does not need to be contiguous. That is, suppose we have the following array. So just consider this following array, right? We can say that if we select elements like we selected this and this, right? That is, after we selected this 4, we did not select this 6, we directly selected this 8, right? So this is the only definition of subsequence, that is, you can leave some elements in between and move to the next elements in any number of times as you want. So this is an easy thing. Let us now understand the meaning of correct bracket sequence. So consider this example. So in this example, as you can see that this is a closing bracket and this is also a closing bracket, and for these two closing brackets there is no opening brackets on the left hand side, right? So they will remain as it is, but for this opening bracket this is a closing bracket, and also for this opening bracket this is a closing bracket. So we can say that this is a correct bracket sequence, and for this there is no opening bracket. And we can also say that this is in itself a correct bracket sequence, and this is also in itself a correct bracket sequence. And if we combine these two, then we will get this, right? That is of length 4. And hence we can say that for this example, the longest correct bracket sequence is what? It is of the length 4. And this is what the question has asked us to print. That is, for each of the opening brackets, you must have a closing bracket. And since for this opening bracket, this is a closing bracket, so this is a correct bracket sequence. And similarly, since this is a opening bracket and this is a closing bracket, so this is also a correct bracket sequence. So we can say that this four characters together also acts as a correct bracket. But there is one more thing to understand about this correct bracket sequence meaning. So now consider this example. So I have extended the given string a little bit, right? So now if I ask you what are the correct bracket sequences present in this example, so you can say me that okay, this is a correct bracket sequence, this is a correct bracket sequence, this is a correct bracket sequence, and this is a correct bracket sequence, right? So now if I ask you to give me or to answer me the length of the longest correct bracket subsequence in this example, then what will be your answer? So if you have read the problem correctly, then it has clearly mentioned here that we want to print the length of the maximum correct bracket subsequence. Focus on this word, subsequence. So that's why if someone asks you to answer the length of the longest bracket subsequence for this example, then it would include this correct bracket sequence, this correct bracket sequence, this correct bracket sequence, as well as this correct bracket sequence, right? So if I now mark them using the red color, then it would be something like this. So this bracket, similarly this bracket and this bracket, and then this bracket, and then this bracket and this. So the brackets that I have marked with the red color are the ones that would be the part of the longest correct bracket subsequence. Because if you draw them separately, then it would look something like this, right? And all of these four individual correct bracket sequence are together forming the longest correct bracket subsequence that the question wants. So that's why for this example that I have considered by myself, for this example the answer would be what? The answer would be 8. That is a total of 8 brackets. These closing brackets will remain as it is. Why? Because for them there is no opening brackets present on its left side. So this will remain as it is, this will remain as it is, this will remain as it is, and this will remain as it is. Only these much of brackets that I have drawn here separately will take part in the longest correct bracket subsequence. And since they are total 8 in number, I can say for this example the answer would be 8. Now you must have understood the meaning of subsequence and the meaning of correct bracket subsequence, right? So now if I try to explain you the original example, then let us start now. So this is the given sequence or the string, right? So let me mark the indexes of this brackets here. So now I have marked the indexes for this example, and now let us start performing our queries. So in the first query, we want to find the longest correct bracket subsequence for this range. That is starting from the first index and going till the first index only. And also keep in mind one thing, that this L and R are given in one based indexing only, right? So it means that this is asking us to answer the query from 1 to 1. So in 0 based terms, we can say that it is actually asking us to answer for 0, 0 range. So if we start from the 0th index and go till the 0th index, then it would include just the first bracket only, that is this bracket, right? If I draw this part of the string separately, then I can say that for the 0 to 0 range, the string would look like this only, right? For this string now, we want to print the longest correct bracket subsequence length. So as clearly visible that this is an opening bracket, and for this opening bracket, there is no closing bracket on its right side, right? So I can say that the length of the longest correct bracket subsequence for this query would be just 0, because this will remain as it is, because there is no closing bracket on its right side. And since this will remain as it is, we did not got any kind of pair of brackets which matched with themselves, that is the opening one with the closing one. So that's why it will be 0 for this. and that's why in the output also it is written 0 here. Let us now move to the next query. So in the next query, it is from 2 to 3, that is from 1 to 2 in 0 based, right? From 1 to 2. So now if I try to draw the second part of the query, that is from the first index to the second index, then it would look something like this only, right? And as also clearly visible here that if we try to match up these brackets with their opposite ones, so for this closing bracket there is no opening bracket, and also for this closing bracket there is no opening bracket in this left part. So it means that they will remain as it is, and since they will remain as it is, we still did not got any kind of correct bracket sequence in this range, that is from 1 to 2. So we can again say that for this query the answer should be 0, and that's why it is again 0, as you can see. So in this way we have performed these two queries, and now we want to move to the third query, that is from 1 to 2. So in 0 based it would be from 0 to 1, right? So now the third query wants us to answer from 0 to 1, that is in this range. So if I try to draw this part here, then it would look like this only, right? So this is the 0th index and this is the first index. So now if you try to match up these brackets, so this is the opening bracket, right? And for this opening bracket, as we can see that this is a closing bracket. So these two brackets will completely match up with each other, right? And that's why we can say for this query, the length of the longest correct bracket subsequence is 2, because we have used all the brackets here, so there is nothing to left. So that's why it is written 2 here. Let us now move to the fourth query, that is from 1 to 12. So this will be interesting to understand. Let's see. So since this is from 1 to 12, so I can say that in 0 based it is from actually 0 to 11th index, right? And if you see also, then 0 is our starting index and 11 is our the last index. So it means that now we have to answer the query for this whole range. So now the query wants us to answer the given string for the whole range, that is from the starting index till the last index. So now if we try to match up the brackets starting from the very start, then it would be something like, we would start from here, and since this is the opening bracket, we would look for the closing bracket on its right side. So for this opening bracket, this is a closing bracket. So this pair is forming a one correct bracket sequence. So let me mark this with green color and move forward then. So I have marked this with a green color now. So now let us continue ahead. So now this is a closing bracket, and since this is a closing bracket, there is no opening bracket present on its left. So it will remain as it is. We will not mark this with the green color. And now this is also an opening bracket, this is also opening bracket, and this is a closing bracket. So we can say that for this opening bracket, this is a corresponding closing bracket, that is this pair is forming a correct bracket subsequence. So let me mark this with green color again, and now let's move forward. So as you can see now, this is a closing bracket, and for this closing bracket on its left side, if you look, then this is an opening bracket. So it means that we can match this closing bracket with this opening bracket, and hence this pair will form a correct bracket subsequence, that is a valid bracket subsequence. So let us mark these two with the green color as well, and now let's move forward. So this is a opening bracket, this is a opening bracket, this is a closing bracket. So since this is forming a closing bracket, that is a pair which is a valid pair, so mark this with green color here, right? And now let's move forward. So this is a closing bracket, and on its left if you look now, then this is an opening bracket which is present. So it means that this bracket can pair up with this bracket, right? So again let us mark this with the green colors, and now let's move forward. So now this is a opening bracket, and for this opening bracket, what it wants, a opening bracket will always want a closing bracket on its right side, and a closing bracket will always want a opening bracket on its left side. So it means that since we do not have any such opposite pairs for these two, so they will remain as it is. And hence if I now try to draw this separately here, then the brackets that I have marked with the green color will look something like this. So it will look something like this, And if you try to calculate the length of this subsequence of the brackets, then what is it equal to? It is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you try to look the output, then as you can see here, that the output for this query is 10 as well. So in this way we performed this query and got our correct output, that is 10. So by now you must have got the idea little bit, like how the outputs are coming for each and every query, like how we are selecting the brackets in pairs and marking them with green colors, that is the brackets that will be present in our answer, and whatever brackets that will be not present in our answer will remain as it is, and we will not consider their length in the result. So let me erase this now and move on to the next query. So let us now move to our next query, that is this. So in this query we have to calculate the result from 8 to 12, that is in zero base terms from the 7th index to the 11th index, right? That is from the 7th index to the 11th index, that is in this part. So if I now try to draw this part separately here, then it would look something like this, isn't it? So this would be our 7th index and this would be my 11th index. So now if we try to match the brackets, then this would be our opening bracket, this would be our opening bracket, and this would be our closing bracket. So since this is a opening bracket, it will always want to find a closing bracket on its right side, and since this is a closing bracket, so this will form a correct bracket subsequence pair, and hence we will mark these two with a green color, that is they will be a part of our result. And now if you try to move forward, then we will get this, that is a closing bracket. So this closing bracket will now want a opening bracket on its left side, which is present here. So this will form a pair with this, that is these two, and hence these two will also be a part of our answer. So we will mark again these with the green color. And now if we try to move forward, then we will get this opening bracket. So this opening bracket will now want a closing bracket on its right side, and if you try to look, then there is no brackets remaining anymore, so we can say that this will remain as it is. And hence the longest bracket subsequence that we will obtain for this query, that is from the 7th index till the 11th index, will comprise of only this part. So if I try to draw this separately here, then it would be this only, and clearly this has a length of what? This has a length of 4. And if you try to look the output for this query, then as you can see it is 4 only. So that's why the output is 4 for this example, for this query. Now let us move forward. So this is my next query, that is from 5 to 11, that is from 4th index to 10th index in our this string, 4th index to 10th index, that is this part, right? So if I now try to, draw this part separately, then it would look something like, this only, right? So this would be my 4th index and this would be my 10th index. So now let us start matching the brackets starting from the very start, that is from the 4th index. So this is the opening bracket and this is the closing bracket, so these two will form a pair, right? So mark this with the green color here and let us move forward. So this is a closing bracket and it will try to find an opening bracket for itself on its left side, but it will not be able to find any, so that means it will remain as it is as of now. And now if we try to move forward, then this is the opening bracket, this is the opening bracket, this is a closing bracket, so this will form a valid pair, and that's why it will be a part of our example as well. And now if we move forward, then this is a closing bracket. So since this is a closing bracket, it wants a opening bracket on its left side in this part, and since this is the opening bracket, so these two will form a valid pair, and hence these two will also be a part of our result. And now if I try to draw the brackets that would be a part of our answer here separately, then it would look something like, so since 6 is missing here, that is this bracket is missing here, so that's why we can say that this is forming a subsequence, and this is what the question has want us to do. And clearly the length of this obtained result is 6, right? And if you look in the output also, then it is 6 here, and in this way we got the correct result for this query. Let us now perform the last query. So the last query is from 2 to 10, that is from 1st to the 9th index, right? That is from 1st to 9th, that is in this part. So if I try to draw this part separately here, then it would look something like, this, right? So let us start matching the brackets now. So this is a closing bracket initially, and it will not get any opening bracket on its left. Similarly, this is also a closing bracket, so this will also not get any opening bracket on its left. Now this is a opening bracket, this is a opening bracket, this is a closing bracket. So since this two is forming a pair, that is a valid pair, so I will mark this with a green color here. That is, they will be a part of our result. And now let's move forward. So this is a closing bracket. So this closing bracket will look for an opening bracket on its left and will get this. So these two will also form a pair now. So let us mark this with a green color here like this. On moving forward, this is an opening bracket, this is an opening bracket, and this is a closing bracket. So since this is forming a valid pair here, so I can say that this will be a part of our answer. And in this way, the brackets that I have colored with green color will be a part of our answer. And now if I try to draw them separately, then it would look something like this. And since the query was from 1st to the 9th index, so this was my first index and this was my 9th index, right? But here if I try to mark the indexes in the result string, then this is actually my third bracket, this is my fourth, this is fifth, this is sixth, this is eighth, and then this is ninth. And clearly visible that the length of the longest correct bracket subsequence for this query, that is of this part, is what? It is 6. And if you try to look the output here also, then it is 6 only here, as you can see. So in this way we performed each and every query given in the question and got the correct results or the outputs each and every time. So by now you must have understood how the outputs are coming for each and every query, and we have to print that query's result only. That is the length of the longest correct bracket subsequence for each and every query's range. So let me erase these things now. So now let us quickly discuss our brute force approach here. We will not give much time to that. So what will be the brute force method? So in the first step, after converting our given values of L and R to 0 based, we would start our iteration from L and will go till R. And in the second step, since we have started our iteration from L to R, so on iterating on each index, we will check if the current character is equal to an opening bracket or a closing bracket. So if it is equal to an opening bracket, so what we will do? We will simply push this opening bracket character into the stack data structure, right? And if this is not the case, that is, the current character is a closing bracket. So what we want for each closing bracket? We always want a opening bracket to be present or a opening bracket that we have encountered in the past. So we will check if the stack is not empty, that is, there are still some opening brackets that are remaining. So it means that this opening bracket that is present here at the top of the stack will now make a pair with the closing bracket that we have just encountered now. And since this will form a pair, so it will contribute a 2 result to our answer. And once this is done, we will simply return our result. So this will be our brute force approach. So let us quickly code this approach in our code editor. So let us first take the inputs. So since we have to take the input of a string as the bracket, so I will say string s like this. And once this is done, I have to take the input of the number of queries, which is equal to m here, like this. So I will start my each and every query here, and for each and every query we know we have an L and an R, and since this L and R are given in one based indexing, so I will do a minus for each one of them, right, like this. And once this is done, I will actually start my iteration from L, starting from L like this, and will go till exactly till R. But also make sure that before starting the iteration we have to use a stack, right? So I will say stack of character, let's name it as st. So I will say if my current character, that is s of I, is a opening bracket or a closing bracket. So if this is a opening bracket, so I will say just st.push this opening bracket. And if this is not the case, that is, it is a closing bracket. So if this is a closing bracket, then what we want? We want a opening bracket corresponding to this closing bracket. So we'll just check if the size of this stack is empty or not. So if this is not empty, then what I will say that, so if this is not empty, it means that a opening bracket is already present at the top of the stack, which is not paired yet with any closing bracket. So it means that this closing bracket can now pair up with this opening bracket, and that's why it will contribute a total of 2 to our result. So let us declare the result variable here. So int result equal to 0 initially, and after the iteration has been performed completely, I will simply print this result, that is this. Just do a return. And also make sure that after adding 2 to our result, since this opening bracket that is present at the top of the stack is now successfully paired with this closing bracket. So we have to do a pop operation, right? So I will say st.pop. And now if I try to run the code, let's see if this is correct or not. As you can see, the results are correct here. And if you try to submit this solution, then you will definitely get a TLE. So I'm not going to submit this, but I have submitted this earlier. So let me show you that. So as you can see, I have submitted this TLE solution here and I got a TLE on the test 13th, right? So this will definitely give a TLE. Why this is giving a TLE? Because if you see the time complexity of this, then as you can see that the total number of queries, that is m, can go up till 1e5, and for each query the range, that is from L to R, can be present between 1 to n. So in the worst case this m can go up till 1e5, right? And suppose for each one of those queries, that is all the 1e5 queries, the range that has been asked to answer is nothing but from the starting index, that is the first index, to the last index. And since this range is quite big, because the n value can go up till 1e6, so it means that we have to iterate 1e6 times for each and every query. So what will be the time complexity total for this? It will be 1e5 into 1e6 in the worst, which is equal to 1e11. So this is an O of n square solution. That is, this is what? This is nothing but O of total number of queries, that is m, into the range of the iteration, that is from L to R, that can be present at the worst case from first to the last index, that is n. So m into n, which is nothing but 1e11 in the worst case. So that's why it is giving TLE on the 13th test case in the platform. So I hope you have understood the brute force solution here. It is of not much use to us. Let us now try to understand the optimal approach using segment tree, and the approach is really very beautiful and you will really like it. So let us now go to the blackboard and understand the optimal approach for this problem. Let us now start discussing our segment tree approach here. Okay, so now let us first revise once how the general structure of the segment tree looks like. So it looks something like this. That is, suppose this is our given array which consists of currently 8 elements. So we know that each element of this array is initially present at the base level of the segment tree, right? Actually this segment tree will contain a total of 4 times of the total number of nodes that are present in this array. That is 4 times the total number of elements present in this array. That is 4 into 8 here, which is 32. But for the simplicity purpose, I just have drawn these much number of nodes so that you can understand better. And the remaining nodes will not play much crucial role because they will be 0. So ultimately our answer will remain same as per the current example. So we know that for a general purpose segment tree, what operations can we do? So it mainly supports 3 operations, that is build, query and update. So for this example, I have calculated the range sum. That is, if we are asked to query the range sum for any range, then this segment tree will help us in this case, right? So as you can see that first element, that is the 0th index element, is 0 and the first index element is 4. So we can say that the range sum from 0 to 1 is 2 plus 4, that is 6 here. Similarly, if this is 1 and this is 3, then it would be 1 plus 3, that is 4. So since this represents a 0 to 1 range and this represents from 2 to 3 range, it means that the combined node here, that is the parent node of these two nodes, will represent these extreme ranges, that is from 0 to 3, and the summation will be nothing but 6 plus 4, that is 10. So the same thing is done for each and every node till we reach the root node. So we know that this is the general purpose segment tree and how this is constructed, that is built initially, right? And how using the query we can compute the range sum for any range we want. And also if we want to update, then we know what actually happens on the ground. So suppose we want to update this one, let's say we want to turn this one equal to 8 now. So what will happen? So we know that we want to update this second index equal to 8, right? So we will start from the root node and it will go down and down until it reaches the second index recursively, right? And once it reaches the second index, it will change this one equal to the 8. That is this value. And once this is changed to 8, it will propagate the changes in the upward direction. That is, this 8 plus 3 will become equal to 11 now, right? So this 4 will become equal to 8 plus 3, that is 11. And since this node has been changed, it means that by the combination of these two nodes, the value of this will also change. And that's why it will no longer remain equal to 10, but rather 11 plus 6, which is equal to 17. And since this node has been changed now, it means that by the combination of these two nodes, the value of this will also change. And that's why it will no longer be 2, but rather 28. So in this way, we understood the build, query and update functions for a general purpose segment tree, right? So this is the standard one, but why I taught you this here again, because in the current problem, it will use the segment tree concept, but it will not use this regular segment tree concept, because what we are doing in this general purpose segment tree, we are just storing the summation of ranges in each and every node, right? So each and every node of this segment tree corresponds to a single value, and that value represents nothing but the sum of that range, right? But in the current problem that we are solving, that is Sereja in brackets, in this problem we will use the segment tree and we will construct or build this segment tree in the same way, but instead of using or storing a single value in each and every node, we will try to store actually 3 values, and I will tell you very soon what those 3 values will be, and using that we will be computing our answer for each and every query, just like we do it here, right? So let us now go and understand how the actual segment tree for this problem will be constructed. So if you remember, then this was our original sequence given, right? That is the brackets. So now if I want to construct a segment tree based on this, then since this is a string, and I think I am more comfortable in constructing a segment tree using integer values rather than the characters of the string, right? So what I will say now is, I will treat each forward bracket, that is the opening bracket, as 0 and the closing bracket as 1, right? So if I do this, then the new sequence will look something like this, right? That is, I have represented each and every forward bracket as 0 and the backward bracket, that is the closing bracket, as 1. So there should be no problem in understanding this to any one of you, I guess. So this is our current array, right, that we just constructed from the given string of bracket, and now I want to construct a segment tree using this vector, that is this array num. So as I told you before, that in the general purpose segment tree we just store a single value in each and every node of the segment tree, but in this question we will require to store actually 3 values in each and every node. So now, as I said, that in each node of the segment tree I will store 3 values. So suppose this is a node, it can be any node of the segment tree, right? So let's say that this node represents the range from L to R, right? So for this node I will store 3 values. The first quantity is left unmatched, the second quantity will be right unmatched, and the third quantity will be result of the current range. So let's see what each one of these actually means. So consider that this is our given sequence of bracket, right? So what does this left unmatched mean? So left unmatched means what? That suppose I'm talking about a particular range. So as I said, that each one of these 3 quantities will be calculated for a range, right? So for now let us consider some range. Let's say I am considering this range, right? That is from the first index till the 6th index. So I am considering this range. So now if anyone will ask you to tell or answer that what is the number of left unmatched for this range, then what will you answer? So this left unmatched means what? It represents the number of bracket, but which type of brackets? It represents the number of opening brackets. So this represents the number of opening brackets, that is these number of brackets which are still not matched with their closing bracket, right? And similarly, this right unmatched variable will represent the total number of this closing brackets that are still not matched with their corresponding opening bracket. And this result of the current range will, as the name suggests, this will store the maximum possible length of the matching bracket subsequence for a given range. Since here I have considered 1 to 6, so we have to answer for this range, right? So let me tell you once again for those who didn't get it at the first go. So we took 3 variables, and I told you that each node will store these 3 variables, and this will store nothing but the result that the question wants us to calculate, that is the length of the maximum correct bracket subsequence, right? So there is no problem in this. But what does these 2 is representing? So these are representing nothing but the number of left brackets and the right brackets that are currently not used or currently not matched with their opposite pair, right? So if I'm talking about this range, that is from 1 to 6, that is this range, then what is the total number of left unmatched brackets? So let us now see one by one. So as clearly visible that these 2 brackets are forming one pair, and these 2 brackets are also forming one correct bracket sequence pair, right? So these 4 are already matched, but these 2 are getting not used, that is they are alone, right? So as clearly visible that these 2 are the closing brackets. So as I told you that a closing bracket will remain the number of right unmatched brackets in that range. So I can say now confidently that the number of right unmatched bracket in this range is 2, and since there is no left unmatched bracket in this range, so it will be 0. And also we saw that since this 4 brackets are forming a longest subsequence correct bracket subsequence pair for this range, so I can now also say that for the result of current range will be, so in this way these 3 variables will be calculated for a given range, and these 3 variables will be present in each and every node of the segment tree. So this will represent our left, this will represent our right, and our result will be stored here, something like this you can imagine. So once you have got the simple concept of left unmatched brackets, right unmatched brackets, and the result of a range for a given range, so once you have got these 3 concepts, let us now actually draw the segment tree structure for this problem and understand how these 3 variables and the node structure that we just built something like this will help us in computing the answer for each and every query. So as I said that it would be very similar to how we do in a general purpose segment tree. The change is only the structure of the segment tree and how we are merging the nodes every time. So currently in the general purpose segment tree, we just used to sum up these 2 values, right? We just sum up these 2 values and get this. But now since we are using 3 variables in a node, so the summing the results directly will not help now. I have drawn the segment tree structure that will be used in this problem, right? So it might be looking to you a little complex, but you don't need to worry because I have drawn it in the best possible way. And as I also said that I will be storing 3 variables, that is left, right, and answer, in each and every node of this segment tree. So I have done that here. And again, keep one thing in mind, that we know that the size of a segment tree is 4 times the number of total number of elements, but I just have considered these much number of nodes, and these much number of nodes will easily help us in answering each and every query, right? Because the other node values will always be 0, so those will not contribute in our answer, so we don't need to draw that. So that's why we don't need to draw that. So now let us start understanding how this segment tree will be built, because we know that what is the first step in any segment tree problem? It is nothing but the build. That is how the segment tree will be built from the base to the top, right? So we know that this is the very first step in any segment tree problem. That is how the segment tree will be built from the bottommost level to the top level, that is the root node, right? So let us start filling the nodes and their values one by one. So we know that what happens in a build function. It recursively travels starting from the root node first to the left side and then to the right side. So once it reaches this 0th index node, it will fill this, and then it will fill this, and then it will combine the results into this node. Similarly, it will then combine the result of these 2 nodes into this, right? And then again the same thing will be done for each and every node of this segment tree. And we also know that these nodes that I have marked with this green color, so these represent nothing but the leaf. That is, these are the leaf nodes which are our actual elements of this array, right? And whatever nodes are present internally, those are called as internal nodes. So you must be knowing this, right? Okay, so let us now start building our segment tree one by one. So suppose now I am standing here, that is the build function has reached here now. As I told you that this 0 represents nothing but this forward bracket, that is the opening bracket, and this 1 represents this closing bracket, right? So since this is a 0, that is the value of element present at the 0th index is 0, so it means that the bracket that should have been present here was a open bracket, right? If this is a open bracket and I am asking you that in this range, that is from 0 to 0th range, that is this range, what is the total number of left unmatched bracket? So it is clearly visible that in this range the total number of left unmatched brackets is nothing but 1 only, that is in itself. Why? Because this current open bracket is not able to pair up with any closing bracket, right? So that's why the total number of left unmatched brackets in this range is just 1. So I will write here in the left variable for this node that the left unmatched bracket is 1. So I can also say that the number of right unmatched bracket for this range is just a 0. And since this leaf level represents just a single bracket, so we know that a single bracket will never form a valid or a correct bracket sequence, because to because to have a correct bracket sequence we at least need this, that is 2 brackets, but the base level represents just a single bracket. So I can just say this, that the answer variable for each and every base level leaf node will just be a 0. So let me fill this for all the leaf levels. So answer for this is 0. Similarly for this, and same for each and every leaf. So as you can see that I have filled the value of answer for each and every leaf level equal to 0. Why? As I just told you that we at least need 2 brackets to form a correct bracket sequence. But since the base level represents just a single bracket, so it will be 0. So now let's come back to what I was telling you. So I was telling that for this range, that is from 0 to 0, I wanted to find the number of left unmatched brackets and the number of right unmatched brackets. So we saw that since this represented 0 to 0, that is this node, that is this element, and this was equal to 0, which represented our forward bracket, that is this, right? So in this range, the total number of left unmatched brackets is just 1, because it is not able to match with any other, and there is no right unmatched bracket. So that's the right unmatched bracket is 0 and left is 1. Now let's move ahead and fill other elements. So okay, now suppose I'm standing at this node. So now I want to determine the total number of left and right for this node, that is for this. And since this is equal to 1, it means that this will no longer be a opening bracket but rather a closing bracket like this. And since this is a closing bracket and I want to find the total number of left unmatched and right unmatched here, so as clearly visible that since this is a this is a closing bracket, so for this closing bracket there is no opening bracket. So I can say that the right unmatched is 1 and the left unmatched is 0. So just do the same, that is right unmatched is 1 and left unmatched is 0. So by doing these two, it should be evident to you by now that for every node present at the leaf level, if it is equal to 0, then the value of left will be 1. And similarly, if it is equal to 1, then the value for the right will be equal to 1. So let me quickly fill for all of these leaf nodes and then we will see what to do next. So now I think I have filled each and every element at the leaf level to their initial value, right? So this has been filled, this has been filled, this, that is a total of 12 elements. Now let us start combining the results of the childs into their parents, right? And as I told you that in the regular segment tree structure we just used to sum up these values or whatever we require. So if we require the summation in this range, then we simply add up these two values, or if we require the bitwise XOR of this range, then we simply took the bitwise XOR of these two ranges, that is these two values, right? But the same thing will not be applicable here. So for those who are thinking that we will simply add the these answer values of the child nodes and put it in here, then this will be wrong. This will be completely wrong. This will no longer be valid here. Why? Let us see what actual thing we have to do in order to compute the result for the parent node, that is to merge the child node. Now consider that this is our current node, that is the parent node, and we want to combine the result of the left children and the right children. So this left children will be representing some range and this right children will also be representing some range, and by combining these two child it will represent the range of this parent node, right? So now it is clearly visible to us that the result value for this range is what? It is equal to 4. And it will comprise of these 4 brackets because this is forming a correct bracket subsequence, right? Similarly, if we look in this range, then what will be the value of result? It will be equal to nothing but 2 only, because these two brackets will only form a valid pair and others will remain as it is, right? So now if you remember, then what I told you before, I told you that we simply cannot add these two results and write here. It will be wrong, right? Why? Because suppose I did that, that is I took it 4 here, I took it 2 from here, and I wrote the summation equal to 6 here. And let's now try to see if this is right or not. So let us start forming the bracket sequence one by one and consider this as a single one because I have combined these two in the parent, right? So now I am standing here, right? And then I will move forward and then it will combine with this. Similarly, this will combine with this. And once I reach here, it will combine with this, right? So let me mark this, the brackets that will be a part of our answer. So now I am standing at this, and as clearly visible that for this closing bracket there is no opening bracket present on the left side, so it will remain as it is, right? It will not be a part of our answer. Now if we move forward, then this is the opening bracket, this is a closing bracket, so these two will form a pair. So let me mark this with a blue plus. So this will be a part of our answer. And now if we move forward, then clearly these three will remain as it is, because for each one of these closing bracket there is no opening bracket present on the left side. And now if you see, then how many brackets are part of our answer? So clearly 1 2 3 4 5 6 7 8. So the actual answer should be 8 only, right? This is correct. But when we summed this directly, we got 6. So that's why I told you that we cannot sum this directly. It will give us a wrong answer, right? So this 8 is our correct answer. I hope you got how we got 8 here. So one thing, if you have noticed here, that what we did in order to actually combine this result. So if I write here mathematically, then this result was nothing but actually whatever the result it had previously here. So I can say that the left result, right, plus the right result, that is the right child's result. So these two will remain a part of our answer. That will not change, right? So 2 from here and 4 from here. But what extra we got? We got an extra of 2 quantity. But where we got this 2 from? So we got these 2 when these 2 brackets formed a pair, right? So these 2 new brackets contributed to a new pair, and thus a plus 2 has been added, and thus our answer increased from 6 to 8 like this. So how can we define this new added term here? So if you look closely, then, and for your understanding purpose, let me erase these things that has already be a part of our answer for now. So this is the remaining sequence, right? And remember, then this was our left child, and this was our right child. So when we combine these, two, then we got an extra plus 2 by these 2 brackets, right? That is, this combined with this, and this remained as it is. Had there been more brackets like this, suppose along with this one bracket there was one more bracket, 2 more brackets like this. So what would have been the answer of this result in that case? Will it remain equal to 8? No. Why? As I told you, that when we have combined the result of both the left and the right childs, so as you can see that these 3 open brackets are now forming a pair with these 3 closing brackets. So actually instead of these 2 brackets, all of these 6 brackets will now be a part of our answer. That is, this will be nothing but 6, that is the summation of the left result plus the right result plus the minimum of whatever the left unmatched bracket is present on the left child, right? Left unmatched bracket from left child, comma, the number of right unmatched bracket from the right child. So right unmatched bracket from the right child. So this is the correct representation for the result of a parent. So whenever we combine, we use this. So now what this is 8 equal to? It is equal to 4 plus 2, let me write that here, 4 plus 2 plus the minimum of number of brackets, that is the left unmatched brackets that are present on the left child, and the right unmatched bracket present on the right child, because these 3 will only combine with these 3 and this will remain as it is, right? So that's why I'm taking the minimum of these, right? So what is the minimum? The minimum is 3. So that's why I'm writing 3 here. But since this 3 just represents the 3 opening brackets, and we know that for these 3 opening brackets now we have 3 closing brackets, so I will just say instead 3 into 2, that is I will multiply 2. So what this is equal to? It is equal to 6 plus 6, that is 12, and thus 12 will be the answer in that. So let me tell you again what this result value will be equal to. So it will be equal to the left result, and this represents the longest correct bracket sequence present in the left child, and this right result represents the longest correct bracket sequence present in the right child. And at last I told you that we have to take the 2 times the minimum of the number of brackets, but what type of brackets? That is unmatched brackets, right? Unmatched. So unmatched of left, comma, unmatched of right, right? So this will come from the left child, and this will come from the right child always. So let me write this note here. It will come from the left child, right? And this will come from the right child, because obviously if we take the right unmatched brackets from the left child, then clearly this will not form a valid sequence pair, right? So we are not considering this, rather we are considering this. That is, we are taking the opening bracket from the left side and the closing bracket from the right side also. So by now you must have got how the result will be calculated, that the node will be merged every time for a parent. Okay, so now since we have changed our example a little bit, let us continue with this example only. So if you remember, then the brackets that were present inside was something like this. So now what I am saying is, this is my left child and this is my right child. And now let us calculate the values of other variables. So the result for this is 4, right? And what is the total number of left unmatched for this range? So the left unmatched is 3, because 3 opening brackets are remaining unmatched, and hence the number of right unmatched bracket is 0 here. Similarly for this, the total number of left is 0 and the total number of right is 4, right? And we derived the formula of result for the parent node like this, but we also have to recalculate this value of L and R, right? Because we still have not calculated the value of L and R, that is the number of left unmatched and right unmatched for this range, that is for the combined node, that is the parent node. So what will be the expression for this L and R? So it will be also calculated in a very similar way as the result. Just see what I am doing and try to understand. So now I want to calculate the value of left unmatched bracket and right unmatched bracket for the parent node. That is the node when we have combined the result from both the left and the right child. So we got the expression for result, but now I also want the expression for the left unmatched and right unmatched. So let us try to evaluate that here. So if you remember, then this part directly went into the part. So if you remember, then this part directly went into our answer. Similarly, this went directly into our answer, right? And also these 3 opening brackets went into our answer with these 3 closing brackets in order to form the longest correct bracket subsequence for the combined range, right? So what was remaining, if you see, so only this was remaining here, right? Only this is remaining. So what will be the expressions for the left unmatched and right unmatched for the combined sequence? So I will say that the left unmatched for the combined node will be equal to nothing but whatever the total number of left unmatched brackets was present in this left child plus the total number of left unmatched brackets that was present in this child minus whatever the common number of left unmatched brackets was used in order to combine. That initially the left unmatched bracket value for the left child is 3. So I will say 3 plus the number of left unmatched bracket for this right child was 0 because there was no such bracket present here. So 0 minus whatever the minimum number of brackets we have used in order to combine with the opposite side. So since here we have combined the all 3 opening brackets with these 3 closing brackets out of the given 4, right? So by doing this, what happened? We lost these 3 opening brackets, don't we? So since we lost these 3 opening brackets, and what is this 3? It is the nothing but the minimum of this quantity that I just explained you before. So I will say 3 plus 0 minus the number of left unmatched brackets that we lost while combining. So it is nothing but 0 only. And that's why I can say that the value of L for the combined node will be 0. And in the same way, if I try to evaluate this right unmatched for the combined node, then it will be equal to the right unmatched bracket value for the left child, that is 0 here, plus the right unmatched bracket value for the right child, which is 4 here, minus whatever the common number of right, that is the closing brackets that we lost. So since we lost these 3 closing brackets, right, so I will say 3. So 4 minus 3 is 1. So I will say the right value is 1 here. So in this way, the value of result, left unmatched bracket and right unmatched bracket for a given range will be calculated. And if you see here also, then what we are getting now, we are getting 0 as the total number of left unmatched bracket for this whole range. And it is true, because if you see, then in this range there is currently no opening bracket present. That is, it should be 0, and it is. And the total number of right unmatched brackets is getting 1 for this whole range, and it is true, because it is clearly visible here also. It is just 1 present. So that's why 1 here. And since the result was the summation of these, which was equal to 12 only, so we got 12 like this. So this is the most important and the crux of this problem that you had to understand in order to build this segment tree. And once you understand this and grasp this concept in your mind, it will become very clear to you how you will write the code and how will you combine the results. So now if we try to do the same thing here in the actual segment tree that I constructed here. So let us start doing this one by one. So it might take some time, but I will do this thoroughly, right? And if you're still watching the video and have not liked or subscribed the channel, so please consider subscribing the channel, because it takes a lot of efforts to create each and every single video, as you can see. So let us now start combining our result. So let us do for this node first, because recursively also it will start combining the result from here only, right? So every time we will first calculate the left, right, and then answer. So as I told you, what will be the value of left? It will be equal to the summation of the values on the left and the right child minus the minimum of left and right of the left and right childs, right? So here the value of this left will be equal to this 1 plus 0, that is 1, minus the minimum of this left and right, which is 1 only. So 1 minus 1, which is equal to 0. So this left will become equal to 0. And what will be the right value? It will also be equal to this 0 plus this 1, which is equal to 1 minus the minimum, which was 1 only. So again 0. So the value of right will be 0. And what will be the value of answer? Answer is nothing but, as I told you, the left answer plus the right answer, which is 0 here, plus the minimum of both of them, which is 1 here. So 1. So I will say that the answer is 1. So in this way, we combine the result for these two child nodes into this. And now what we have to do? We have to combine the result of these two child nodes into this node. So let us do that quickly. So what will be the value of left? It is equal to here. It will be equal to 0 plus 0, that is 0, minus the common thing, that is minimum of 0 and 1, which is 0. So 0 minus 0 will remain 0, so 0. Similarly, for the right, it will be equal to 0 plus 1, which is 1 minus 0, so 1. And answer will be equal to 1 plus 0, which is 1, plus the minimum, which is 0, so 1. So in this way, the result for this range is also calculated. And as soon as our build function has calculated this, it will move to this node, right? So let us do that here quickly. So let us do that here also. So this left will be equal to what? So this left plus this left, which is 2, minus the minimum of left and right, which is nothing but 0 only. So 2 minus 0, which is equal to 2 here only. So I will write 2 here. And right will be equal to what? It will be equal to 0 plus 0, which is 0 minus 0. So 0. And answer, so 0 plus 0 plus minimum, which is 0. So this will also be 0. And now if I try to combine the result for these two child nodes for this node, then what it would be equal to? So left will be equal to 2 plus 0, that is 2, minus the minimum. And now if you see, then the minimum for this is 1, right? So I will say that 2 plus 0 is 2 minus 1. So left will be equal to 1. Similarly, the value of right will be equal to 0 plus 1, that is 1, and 1 minus 1, 0. So it will become 0. And the answer value will be 0 plus 0 plus 1, that is. And once I do this, what I have to do next? I just have to combine the result for these two nodes into this. And let's say, so this left value will be equal to what? So since the minimum of this and this is 0 only, so I will say left value is what? So the left value will be equal to this 0 plus 1 minus minimum, which is 0. So 1 only. And similarly, the right value will be equal to what? It would be equal to 1 plus 0, that is 1, minus minimum, which is 0. So 1 minus 0, 1. And this answer will be equal to what? So it would be equal to this 1 plus this 1, that is 2, plus the minimum of the both the sides, which is 0 here only. So 2. So it will remain equal to. So in this way, I have successfully calculated the value for each and every node present on the left side. Right. So let us now do the same thing for the right side as well. So let us now go to this part. So now we have to combine the result for this parent node, right? So it will be equal to 0 plus 1, that is 1, minus the minimum, which is 0 here. So 1 minus 0, it will be equal to 1 only. Similarly, now let us combine for this parent node, that is this. So the left value will now become equal to what? So it would be equal to 1 plus 1, 2, and 2 minus minimum. So what is the minimum of this 1 and 0? So it is 0 only, right? So the minimum is 0. So I can say that the left value will be equal to 1 plus 1, that is 2. And similarly, the right value will be equal to 1 plus 0, so 1, and answer will be equal to 0 plus 0 plus 0, so 0 only. And once this is done, I think we have to go to this part, right? So here the minimum, so now we have to calculate the answer for this node. So the minimum of 0 and 1 is 0 only. So I will say that the left value will be equal to now what? So it will be equal to 0 plus 0 minus 0, so 0. Similarly, the value of right will be equal to 1 plus 1 minus 0, so 2. And answer will be equal to 0 plus 0 plus 0, so 0. And now we have to combine the answer for this node. So I will say that the minimum is, since the minimum of this and this is 0 only, so the value of left will be equal to 0 plus 1, that is 1. Similarly, the value of right will be equal to 2 plus 0, so 2. And the value of the answer will be equal to 0 plus 0 plus 0, so 0. And once this is done, now we are ready to calculate the answer for this node. So it will be now equal to what? It will be equal to, but again, let us first see the minimum value. So the minimum of this 2 and 2 is 2 only, right? So now we have to calculate the result for this node. And now if you see here, then the minimum of this 2 and 2 is 2 only, right? So the value of left will become equal to what? It will be equal to now 2 plus 1, 3, and 3 minus 2, so 1. Similarly, the value of right will be equal to 1 plus 2, 3, 3 minus 2, 1. And the value of answer will be equal to what? It will be equal to 0 plus 0 plus 2, that is 2. And once we have calculated these two values, now we are ultimately ready to calculate the answer for the root node. So I will say that the left value will now be finally equal to what? It will be equal to 1 plus 1, that is 2. 2 minus minimum. So what is the minimum of this 1 and 1? 1. So 2 minus 1, which is 1 only. Similarly, the value of this right will be equal to 1 plus 1, 2. 2 minus minimum, that is 2 minus 1, which is 1. And finally, this answer will be equal to what? This answer will be equal to this 2 plus the minimum, which is 1. So 2 plus 2, 4 plus 1, so 5. So in this way, I completely filled this segment tree, right? And those of you who are wondering that how the result for this entire range for the given example is coming out to be 5, because if you see the given sequence in the input, so this was our given input, right? So now for the whole range, our answer is coming to be 5. But here if you try to see the brackets that will be a part of our answer, so let me mark those brackets with some other color. So this will be a part, this will be our part. So these brackets that I have marked with the pink color will be a part of our answer. So can you count how many of these are present here? So it is equal to 1, 2, 3, 4, 5, 6, 7, here 9, 10, right? So a total of 10. So I can say if the query has asked us to calculate the longest correct bracket sequence for the whole range, then it will be equal to 10, right? But what we got? We got 5 if you see here. So 10 is nothing but twice of it. And this is true because in each and every node of this segment tree, we are not storing the total number of brackets for that whole range. Obviously you can do that, it will be absolutely correct. But what I did here instead is I just stored the half the total result in each and every node. So for some node, if the answer value is something, then the actual number of brackets that will be a part of the longest correct bracket sequence for that range will be the double of that answer, right? So if you want to store the actual value of the result in each and every node, you can do that too. There is absolutely no problem. But I think this is a more better way to understand, because this left is actually denoting the total number of left unmatched brackets in that range, and this right is actually denoting the total number of right unmatched bracket in that range, right? And this answer is just denoting the half the total number of brackets that are a part. So since here the value of left and right is 1 here, so since the value of left and right that we got is 1, and as you can see in the example also that this is a right bracket and this is a left bracket which is present alone only, right? So that's why 1 1 for these, and in this way we build our segment. So once we have understood how we will build this segment tree, so I guess half of our work is done already, right? Now we just need to answer each and every query. So when I was explaining you the brute force method, I actually explained you each and every query one by one, how the outputs are coming for each one of these, right? So and now if I want to explain you the same thing for each and every query for this segment tree, then the video will become too much lengthy, right? So I have decided to explain you this query for whose the output is 6. So let us now start discussing this query only, and I think by understanding this query you will be able to realize how the other queries will work. And once you are able to understand the output for this query, you will be very clear with how the other queries will be calculated in a similar fashion. So let us start now. So this query wants us to calculate for this range, that is from 5 to 11. So in 0 based, it wants us to calculate from 4 to 10, right? 4 to 10. So L is 4 and R is 10. So L is 4 and our R is 10, right? So we want to calculate for this range. So we want to calculate for this range, right? Now let us start from the root node. So what happens at the root node initially in the query function? It will calculate the mid value, and mid value is equal to nothing but 0 plus 11 by 2, which is 5 here. So the mid value will be equal to 5 here for this root node. Since this range LR lies completely inside this, so what will happen? It will go in both the directions, right? So it will go in both the directions. So first it will go to the left and then it will go to the right. So let us now first explore the left part. So suppose I am here now, and now it will again calculate the mid value. So again the mid value will be equal to 0 plus 5 by 2, that is 2 only. So mid value here will be equal to 2. So it means that this part will now hold the result for every base level node from 0 to 2 only, right? But since we have to start from 4 here, it means that we will not explore this part. And that's why I will just return a 0 here for each of these 3 variables, right? Because we don't want to explore this part. Why? It is going from 0 to 2, but we have to start from 4, right? So there is no purpose in going to this part, right? So now we will come to this part. And now if you see, then this range is from 3 to 5, and this 3 to 5 lies partially in this range, right? So again we will go in both the directions like this. So first we will explore the left part. So currently it is standing here, and now it will again calculate the mid value. So it will be equal to now 3 plus 4 by 2, that is 7 by 2, that is 3. So mid is 3. So it means that this left part will contain values from 3 to 3, but we know that we have to start from 4. So again we will not go to this part. So again we will return some null value, right? And now we will go to this part, and once we go to this part, we encounter 4 till 4. So the mid value of this will be equal to what? It will be equal to 4 plus 4, 8 by 2, which is equal to 4 only. And this completely lies in this given range, that is 4 to 4 lies completely within 4 to 10. What I will return? I will return this node. So earlier in the general purpose segment tree, we used to return the sum value, right? But since it is storing all these 3 values, so now I will return this node, that is all these 3 values. So it will return that. And once we have explored this part, we will now go to this part. So when we come to this part, again this 5 comma 5 completely lies within the query range, right? So it will again return this node, and hence at this node what will happen? It will combine the results of these 2 nodes, right? So after combining the result for these 2 nodes, that is 4, 4 and 5, 5, because this 4 and 5 completely lies in this range, right? So what will happen after combining the results? Let's see, and let me write that here only. So if we combine the result of this 4 and 5, then what will be the value of left? Left value will be equal to 1 plus 0, that is the left of this plus the left of this minus the common value. And what is the common here? The common is minimum of left of this and right of this, that is the minimum of 1 and 1, which is equal to 1 only. So the value of left for the combined node will be equal to what? It will be equal to 1 plus 0 minus 1, that is 0. So currently my left is equal to 0, right? And similarly the value of right will be equal to what? The value of right will be equal to this 0 plus 1 minus 1, so again 0, so 0. And what will be the answer? Answer will be 0 plus 0 plus 1, so 1, so 1. So by now this is the status of our node, right? And now after we have explored the left part completely and got the results from 4 to 5, we still need our result from 6 to 10, right? We still need our result from 6 to 10, which is present in this range, or this part rather. So now that's why we will explore this part. So now I'm standing at this node, right? What is the range? The range is from 6 to 11. So again, if you see, then we have to go in both the directions, right? So first we'll go to the left part, and now we are standing at this. And now if you see, then this is range from 6 to 8, which completely lies inside this, right? So it means that we don't have to go any further. We will just return this node, right? And now if I explore this part, then now I'm standing at this node, right? So since it lies partially, it means that I again have to go in the both the directions. And now I'm standing at this node, and this node represents what? This node represents from 9 to 10, right? And this 9 to 10 clearly lies within the query range, right? So that's why we will also return this node from here only, and we will not explore this part because this lies outside, right? So what we have returned now? We have returned this node and this node. So we have to combine the result of these two nodes into something, right? So now if I try to combine the results of these two nodes, then what it would be equal to? So the left value will be equal to 2 plus 0, that is 2, minus minimum. What is the minimum? The minimum is 2 only, so 0. Similarly, the value of right will be equal to 1 plus 2, that is 3, 3 minus 2, that is 1. And the answer will be equal to what? It will be equal to 0 plus 0, so 0 plus minimum, which is 2, so 2. So I can say now that when I explored the left part starting from the root node, I got this result. And when I explored the right part starting from the root node, I got this result. And now what we have to do finally, we just have to combine these two, right? So on combining these two, what we will get? Let's see. So the value of left will now become equal to 0 plus 0 minus the minimum. And the minimum here is what? The minimum here is minimum of this 0 and 1, which is 0. So the value of this left now will be equal to what? It will be equal to 0 plus 0 minus 0, so 0. And the value of right will be equal to what? It will be equal to 0 plus 1, that is 1 minus 0, so 1. And finally the answer will be equal to what? The answer will be equal to 1 plus 2, that is 3, minus minimum, which is 0, so 3. So we got the answer for this query as 3. And what I told you before, I told you that whatever answer we will get for each and every node, the double of that will represent the total number of brackets that will be a part of the longest correct bracket subsequence for that query range, right? So since here we got 3, so the double of 3 is 6. And let us check if the answer for this query was 6 or not. So if you see here, then it was indeed 6. So literally I have explained you each and everything in super detailed. This will be the best video on YouTube for this problem, right? And this is a very good problem in order to practice for the segment tree part. So now I have explained you the build function, and now I have also explained you the query function, right? And since we just have to answer the queries, and there is nothing as update in this question. There could have been, but for the simplicity there was no update function needed in this problem, right? So we just need these two, that is the build and the query. So I think I am done with this right now, and now we just need to code this optimal approach in the VS Code editor, and have to see if that is getting submitted correctly or not. So let us now go to the code editor and code this up. So initially we have to take the input for the string, and after that what I told you, I told you that I will represent each of the characters, that is the opening bracket as 0 and the closing bracket as 1. So for that I will be storing the same thing in a vector with initially each and every element equal to 0. And now if I traverse the whole string, so I will say now that if my brackets of I is equal to a opening bracket, then I will assign a 0 value to this index, otherwise I will assign 1, right? So in this way I will fill this array, and once this is done I have to take the input for the number of queries, and since this L and R are given in one based as I told you, so we have to do a minus for each one of them, right? Once we do this, what we have to do, we have to calculate our answer. And as we saw in the explanation, that whatever the result it will return, we have to print the double of it, right? So I will say 2 into whatever the result it will return, that is this query, and then a indel, and then finally return. So now let me quickly declare my segment tree template here. So now let's initialize the segment tree. So I will say segment tree and will give the name of T, and I will pass this brackets array here only, like this, right? So in this way my segment tree will be initialized. So now let us start writing the segment tree class here one by one. So as I told you that each node will store 3 values. So for that I will declare a struct like this, that is struct of node, like this, and it will contain 3 values, right? So I will say now that the first variable will be my left, the second variable will be my right, and the third variable will be the result for that range, which is 0 here, right? So let us write a constructor for it. So in this way I have written the constructor here, and in this way I have also written the structure for each node, right? Now what we have to do, we have to start writing the segment tree class here. So now let me copy the standard segment tree template here, and then I will modify that. So this is my standard segment tree template here, right? Which supports mainly 3 operations: build, query and update. And as we saw that we don't need this update function at all in this problem, right? We only need this query and build. So let us now start modifying our code. So what we will say now, as I told you that in order to assign the value for the leaf level, I will check that if the value for this current element is 0 or 1. So if it is 0, then what does it represent? This represents nothing but opening bracket, right? So this represents an opening bracket like this. And if this is an opening bracket, then I told you that I will say that the left part will be equal to 1, that is the number of left unmatched bracket. Similarly, if I say the same thing, and if this is not the case, that is, this is a closing bracket. So if this is a closing bracket like this, then I will say that tree of node dot right is equal to 1. And one more thing, since the structure for each node is a node here, so just replace this int with this node. It will no longer be a single 0, but rather 000. Like in this way I have modified this and wrote the base case for the build function. And now what I told you that we have to combine. And now after the left part and right part is explored, what we do, we combine the result for the left and right child, right? So I will write a merge function like this, and I will just pass the left and right nodes, that is child. So I will say tree of 2 into node plus 1. I will pass this, and I will also pass tree of 2 into node plus 2, like this. So let me quickly write this merge function here. So this will return a node type only, right? So this, and let me name this as the left child like this, and the second parameter as the right child, because they are the left and the right child, right? So now I will say that, okay, I will declare a new node here. Let's say it as temp and initialize with everything to 0, right? Once I do this, what I have to do next, I have to merge. And for the merge, I gave you 3 formulas. That is, I told you that the result for the combined node will be equal to what? So it will be equal to the result of the left child, that is lc.result, plus the result of the right child, that is rc.result, plus the common thing, right? So what is this common thing here? So this common thing is so this common thing here is nothing but the minimum of the left unmatched bracket for the left child, that is lc.left, and here rc.write. So this is my common, it is the common number of brackets that will match. So this, and what will be my combined left value? So this will be equal to nothing but, as I told you, that it will be equal to lc.left plus rc.left minus this common, right? And in the same way, the right part would be equal to lc.right plus rc.right minus common. And at last, just return this temp. So in this way, I have written my merge function here, right? So this will return this node type, that is temp, to this, and it will be stored here. So I think I have, so now I think I am done with the build function. Let us now come to the query function here. When it goes out of the range, then what we have to return? So instead of returning a single zero, I have to return a triple zero here, like this. That is, the value of all left, right and result from this side will be 0. This query will also return a node, right? A node here in the data type, and this too will also be a node then. And what we have to return then? We have to return the merge of this left and right. So I will say merge of LR, that is this, for the left part and the right part. So this will return me the merged result for the left part and the right part. So now, since this query is a node type, so I will store it, let's say give it a name of, and I just have to return what? I just have to return this nodes result. So this, and once I have written this, I think I have written the code, that is the query function properly, and this merge function here, this query function, and this build function, and I have also declared this structure here. So once I have written this, let us now run the code to see if this is correct or not. Sorry for this silly mistake here, I have written wrong here. It should not be like this, rather it should be like that. If I want to store for the ith character here, then I have to check for the string only, right? So I will check that if my s of I is equal to the opening bracket. So if it is equal to opening bracket, then it will be equal to 0, otherwise it will be equal to 1. So sorry for that silly mistake, I directly compared it with these brackets. It should not be like that, right? So now if I run the code, then, and now as you can see that it is giving me a correct. And now if I try to submit this on the Codeforces platform, let's see if this is completely correct or not. So as you can see, it is accepted now. So thank you so much for watching this video, and I tried my very best in order to explain you this harder problem, which is rated 2000 also. So thank you so much for watching this video. I really hope that you understood the underlying concept, like how we use the brute force first using stack, and then we realized that it was giving TLE, and then we come to the optimal approach. And then we came to the optimal approach, which used a segment tree, but we also saw that this segment tree was not usual because each node here was storing 3 parts, right? So I built the segment tree from the very start for the given example in very detail, and after building the segment tree, I explained you one query, how the result was calculated for each query, and what mathematical formula was there for each of these 3 variables, that is the result and the left unmatched bracket and the right unmatched bracket for a given range. And then I just coded it up like this, and hence we got the correct output and got it accepted on the platform. So if you have any suggestions regarding anything, you can comment in the comment section. I will read those comments and try to act on it. And please do not run away from these harder topics, because this is something that will give you edge in an interview, right? So don't run from these harder topics. If you have not subscribed the channel yet, please consider subscribing, because creating each and every video take a hell lot of efforts every time, right? So thank you so much for watching this video, See you in the next video. Thank you.